Hola. Let's try this problem. 1/3 tan squared x minus 1 equals 0. We know that the first thing we need to do is isolate our tangent expression. So I'll go ahead and move the 1 to the other side. Next, we have multiplication by 1/3. So I'll multiply both sides by the reciprocal of that fraction. Multiply both sides by 3/1. That'll cancel the fractions and leave me with tan squared x equals 3. Now in my final step, it may look like tangent's been isolated, but we really have a tan squared when we should have just tangent. So at this stage, I'm going to take square roots of my expression. Now the square and the square root will cancel each other out, leaving me with tangent x equals radical 3. This, I just made a mistake. This is the most common mistake that students make. They take square roots on both sides and they say, okay, I'm done. Equals square root of 3, unit circle, and go on. But actually, this is just half of the equation. When we take square roots on both sides, let me make a big skull here. Okay, for danger, as in watch out, common mistake territory. When taking square roots on both sides of the equal sign, you must use a plus or a minus, okay? So once again, when we take square roots on both sides of the equal sign, you must use plus or minus. So actually, tan x equals plus or minus radical 3. In reality, we have two equations here, not just one. So I'm going to split this up into two pieces. On the one hand, we know tan x equals positive radical 3. And on the other, we know that tangent x equals negative radical 3. So for example, before we dive deeper into that, if I had, for instance, x squared equals 4, and I take square roots on both sides, you can see the problem with getting this answer. 2 isn't the only thing that if I squared it would give me 4. The other answer is negative 2, because if x was negative 2 and I squared that, it would also give me 4. So once again, remember that when you take square roots on both sides, you're going to get two answers, one plus and one minus. And so that's what we did here. So we're working with two equations at the same time, which is pretty cool. So on the left side, I have tan x equals radical 3. Now remember that radical 3 represents y over x. So on my unit circle, I need to know where, if I have a y and an x, I'm dividing them. By the way, let's put this over 1 so we can see my y is radical 3, my x is 1. That I should end up with a positive answer. So that could happen in quadrant 1 because I would have a positive x and a positive y. So when I divide them, I'll get positive radical 3. I would also have a positive tangent in quadrant 3 because in quadrant 3 I have a negative x and a negative y. But when I divide negative y over negative x, those also cancel and become positive radical 3. So we do know that these are the two quadrants. Let's drop the perpendiculars. Now we know that the y side is radical 3 and we know the x side is 1. This should look really familiar. This is actually one of our special right triangles. You should recognize the sides 1 radical 3 and 2 being a 30, 60, 90 triangle. Another way you could recognize this is, notice that if I had drawn a circle, that the radius of our circle is actually 2. This is not a unit circle, it's a radius 2 circle. So I can make it a unit circle by dividing everything by 2. So now I have a radius of 1. Does that look more familiar? It should. The sides 1/2 and root 3/2 lie on our unit circle. So then the question is, well, what is this angle? Notice it's across the radical 3. That means it's the bigger angle, meaning it's our 60 degrees, not our 30 and not the 45. Well, if this reference angle is 60, that means automatically that this reference angle is 60. Now that we know our reference angle, we label it as always. And our last step for this half of the problem is to find our first angle and our second angle, the actual answers. So our first angle will simply be the reference angle since it's in quadrant 1, that's 60 degrees. Our second angle will measure all the way out here, so that's going to be 180 plus 60 degrees, leaves us with 240 degrees. So far, so good. We need to convert these to radians to satisfy the conditions given in the instructions between 0 and 2 pi, that's in radians. So let's finish this up. 60 degrees we know is pi over 3. We also know 240 is a multiple of 60 because that's the reference angle. So I'm going to write blank pi over 3 and thinking to myself, what times 60 gives me 240? That number clearly is 4. 4 times 60 is 240. So the second answer then is 4 pi over 3. And that's the walkthrough of the first half of this problem. So we've only done the tan equals positive root 3 part of the problem. Pause the video here and see if you can try to do the tan x equals negative radical 3 part. Okay, I hope you had a chance to pause the video and give it a shot. I'm going to put this over 1 and label this y over x. And now I'm thinking to myself, where is tangent negative? Well, that can occur in quadrant 2. Why? Because I have a negative x and a positive y. When I divide, I'll get a negative answer for tangent. But it could also occur in quadrant 4. Because I have a positive x but a negative y. So when I divide those two, I'll also get the negative tangent that I'm seeking. So I know the quadrants. Now I'll drop the perpendiculars. Our y again is radical 3 and our x is 1. Again, radical 3 and 1 for the y side. It's always the up and down. And then the x side is always the horizontal. But notice our signs here. The y on this one is positive because it's above the axis and that one gets a negative. Whereas on the right side, this one is positive because it's a positive x. And this radical 3 will get a negative. So check your signs for accuracy. In our last step, again, you're always, once you have your triangles drawn, your job is to figure out the reference angle. So this guy right here. Since it's across the radical 3, we know it's going to be the larger angle, making it a 60 degrees. Same with this one. Last step, we just need to calculate our final answers. From 0, measuring out this way, see if you can figure out both angles on your own. Pause the video, give it a shot. So the first one was 180 minus 60, which leaves us with 120 degrees. And for the angle in quadrant 4, it would be 360 minus 60 degrees, giving us an angle of 300. Pause again, see if you can get into radians. So since our reference angle was 60 degrees, we know that both of these are going to be something pi over 3. They'll both be multiples of 60. And what times 60 gives me 120? That number is 2, so 2 pi over 3. And what times 60 gives me 300? The answer is 5, so we get 5 pi over 3. I'm going to box my answers. Now, remember where we started. By the way, we're done here. But remember where we started was with this equation. So since we had a square, we were actually separated out into two distinct problems. So to answer the question once and for all, my answer with everything included is theta equals pi over 3, 4 pi over 3, 2 pi over 3, and also 5 pi over 3. The key step was to remember, I'm going to highlight it so you can highlight it in your notes. It was this guy right here. Make sure that when you take square roots on both sides, you put the plus or minus. If you forget to do that, you're going to completely miss that side of the problem. You're only going to get the positive number, and you'll be missing 2 solutions out of the 4. Hopefully that helped, and I'll see you next time.